Okay, guys, welcome back. This last talk today is about event-driven change data capture using Apache Pulsar with Mary. Please welcome her.
Thank you, Anders. Yeah, thank you. Thank you, everyone, for coming to my talk. I know this is last session of the day, so for you to come, and there are other choices for you. So for you to come, thank you very much. So yeah, so today my talk is on event-driven change data capture, and specifically too is like a topic too that we're going to be leveraging on Apache Pulsar. Actually, may I ask first of all to how many of you have heard of Apache Pulsar? Oh, okay, quite a few. That's good. Are you already working with Pulsar, actually? Curious, too, if folks working with... Okay, no problem. How many of you are using Apache Kafka, maybe? Yeah, probably, yeah, a lot more. Okay. I just want to kind of get an understanding, because, too, it probably will be worth it just to introduce to you Apache Pulsar as well. So that's for today. And actually, I forgot to give my QR code, but I will be sharing the slide deck with everybody, too. And just give me a second. This looks to be kind of loose, so I have to reattach. Okay. So who is Mary? So just a quick introduction. I'm a streaming developer advocate at DataStax. And how many of you, just out of curiosity, have heard of DataStax, maybe? Yeah, okay, great. Are you using Cassandra, maybe? Yeah, maybe Astra DB, yeah. So that's cool. So yeah, so that's the flagship product is Cassandra. But about a year and a half or 2 years ago, a company started doing streaming. Event streaming, that's kind of like the thing now, real-time data streaming. So we're adopting Apache Pulsar. So I got hired to join the team with the streaming developer, actually I should say streaming team. We're kind of like a startup within a startup company. It's kind of very lean too, so I'm the only traveling advocate actually for the Apache Pulsar Astra streaming product at DataStax. So as such, DataStax is a database as a service company, managed cloud, but there's also Cassandra, our DataStax enterprise, like database system, which maybe some of you are familiar with too. That's the main thing, but now moving more to streaming, real time, and even now moving towards like doing AI, things like that too. And previously, I was with IBM for about 3-4 years, close to 4 years as a developer advocate in the Java advocacy team. So I was actually back in 2020, I was here for JFocus as well. So just really happy to be back again. So thank you for everybody. I'm based in Chicago. I'm also a Java champion and also president of the Chicago Java Users Group. I'm also active community contributor. And before that, I was a developer, engineer, have worked with various things too. So that's my background, and that's how you can connect with me. But I'll share the slide deck with you again. So this is today's agenda. First of all, it's about why change data capture and what it is. And examine too as to why, the CDC is not all new kind of technology and things like that. So we just want to kind of take a look into some history and background as to why it is important. And then in the modern day now, we have technology like event streaming that's actually very, very much, we can leverage on that to kind of implement like modern CDC system. And then I'll introduce to you Apache Pulsar, and then also do a very quick kind of demo using our company's Astra streaming platform to do an Astra database too. So yeah. Okay, so first, why change data capture? So what is CDC for, right? So it stands for change data capture. As such, is you want to be able to, first of all, we all know data exists in, kind of broadly speaking, right? 3 states, like data in storage, data at rest, and data in use, like that. But the thing is, with change data capture is something that happens in the storage side, in this case, right? Some change in data in the column in the, your database, then you want to be able to capture that and do something with it. And then, essentially it's like a trigger you trigger some action to it. So CDC essentially is a design pattern, right? And it's basically is for serving data sources, right? Such as databases, very typical database, any kind of data source, data lakes, data warehouses, like that. And essentially, too, over here is about, you need to detect and have some process that's observing changes to your data that you want to observe, and then capture the changes, and then transform, do some transformation to it. And essentially, too, not just transform it, you want to propagate the changes to downstream system. So this kind of like goes into like we're talking about building data pipeline. So that's why I think the Apache Pulsar will be kind of a perfect tooling that you can use to kind of enable this pattern. So, okay, so just quick, just assuming folks may not be as familiar with change data capture, so just some basic thing first. So bear with me if you're already working with it. But essentially, too, right? We talk about data source. Again, first of all, we have something to detect it, right? So it's kind of leveraging on an event type of approach. You're kind of, the good thing about doing things in an eventful way is that it can be asynchronous. You don't need to be sitting there and waiting and blocking off other things too. So that's the idea. You have some process out there and observing the changes. And the nice thing about it is everything is in real time. As soon as something happens, then you want to do something to it, which is capture, right? Capture the changes. You detect the changes and capture it. And then basically with the capture, you send it over to a process that essentially you want to transform it, right? You kind of have the data change, you want to transform, filter it, or do something to it, transform. And then you not just like transform it, you need to be able to, so to speak, like send it to downstream like system too, and propagate these changes. So that's where like CDC is. So as you can see, it's not like very complicated as such. I think in the old ways would be like doing things, I shouldn't say like very old, but like traditional way would be like database, you have triggers. You set all these triggers, it's done in your database, right? So that's kind of traditional way. And also too, not just that, right? There's also extract, transform, load, ETL system too. They are kind of form of also kind of larger CDC pattern, right? And you're doing things like, extract some data, maybe like in a batch type of processing, you transform it, and then you load it up to some databases. Now, the disadvantage of such is that while it is very robust, the process and everything, it's really about more synchronous, the way things are being done. You need to process data in batches as you gather all the changes. But as such, right, doing things in a synchronous manner, we know it is kind of not ideal, not fast, and not real time. Not only that, too, for some large sets of data, it will require a huge network bandwidth as well. So then now, other things too, not just that. I think they also, basically these traditional ETL tools are very expensive. They tend to come from, I think, like big companies like Oracle, and also some other, right, IBM and all these companies. They charge you a huge sum of money. And they are not open source in general. So it's expensive, and all the setups too, not to mention all the setup quite heavy, and essentially not very modernized. And I think it has its place in the computer world, but it's for the modern times that we're living in. We want everything to be done fast, and we want everything to be done in real time or near real time. So this may not meet the the requirements that we have. And besides too, all of the ETLs do involve a lot of data, like file I/O or database, like any kind of disk I/O will increase your processing time too. So that's why we're kind of like looking into like event streaming, in which everything can be done fast. Before you even hit the disk, it's done in memory, like that, such as an event streaming platform. Okay, so now then, let's take a look at the components of a CDC system. While it is kind of simple, but let's take a look, right? And this is just a diagram illustrating it. Change detection is one thing. Oh, sorry. Change detection, and then the change capture side, and then the propagation. But it's kind of still not very complicated, but that's what essentially make up a basic kind of CDC system. So now then, let's also take a look too at CDC. Essentially too, it's also a log-based system, because we're like, looking at the change of your data as it progresses through time. And essentially too, like if you look into log-based CDC, right, there's an example over here. You are setting some data, some process coming in and set the column x equals 1, another one comes in x equals 2. So we are tracking all of these in a transaction log, right? So as you can see, this is an example over here. We sense that there's some changes, and then you're doing all the transaction logging. But ultimately, too, like what goes into the target data file system will be like the latest, which is in this case, you're writing x equals 1, then x equals 2, then the latest is the current state that we're looking at. This is kind of a log-based type of CDC approach. So let's then take a look into this modern CTC-like requirement. But let's also understand too, in modern, what does it mean, right? It's kind of open too. But in today's world, when everything is in the cloud, then we're talking about cloud-native systems. And not only that too, I think there's actually a challenge too when you get to CDC system is the fact that it is a distributed system. You can have multiple servers that are replicated nodes and everything. They're running, different things, and you may run into timing type of issue. Maybe, what happened is if like one, node is processing something, another node is writing to it. So you may run into this kind of timing type of issue, all of these things, kind of complex. But most of the time too, we don't think of it, especially maybe if we're implementing business logic, we're just interested in making sure the outcome is correct. So we want to make sure we rely on a system that can handle all of these complicated concurrency, like event timing, all of these things in a, kind of a very efficient and also an very accurate way too. You want kind of a consistency in the data too. So cloud-native systems is what we're looking at, right, for a modern system. This kind of environment is becoming more and more important now. Not only that, too, you want systems to react really fast. It's very responsive. You want systems, no longer the old way, batching it up. In a lot of cases, you want immediate kind of reaction to these changes that occur. And then, of course, too, there's also scalability, and especially in systems that maybe you are observing tables with, that are reading data from an IoT apps that have devices that are scattered in the field. They are sending data to an IoT servers and all these things. And all of a sudden, temperature changes. You keep, kind of like sending data, that type of stuff. You want the system to be very scalable, essentially scalable and elastic, right? And then you want to make sure that you can add nodes, and servers to your infrastructure. So then, all the data needs to be all in sync to that type of stuff. So, and not only, all these being cloud-native, responsive, and scalable, you want the system to be very resilient. So if something happens, you want it to be able to recover quickly or have some ways of kind of bouncing back. So this is kind of like more like an, general definition of a modern system. And now, then also, let's take a look too, right? Transmission, okay, then we're now getting into, okay, that's modern system, some abstract idea. But we need to look into, we're dealing with data. They are messages, right? Basically, we're talking about transmitting data as messages. So all of these, like features must, or kind of like properties must exist, in like for example, like a change data capture event streaming system is over here. Like we want system to be, again, very reliable and very resilient. So you want that, that system to also have built-in like quality of service, kind of guarantee. Your delivery of messages needs to be guaranteed too. Many things are happening, but you want to make sure messages don't get dropped. And then you want it to be very responsive. So in order to be responsive, you want to make sure the system is lightweight and also the loosely coupled type of way of doing things, kind of especially, say, in microservices kind of approach, right? And largely, generally speaking, loosely coupled, decoupled type of system, very asynchronous. Those are kind of properties in your system. And scalability can also be achieved by essentially using a PubSub type of messaging system. As you know too, PubSub, just a quick thing, is that if you're not familiar with this, is publish, subscribe. These are messaging systems in which the publisher, subscriber, they don't need to know the address of your sender or receiver, vice versa. And you're relying on a broker to deliver, get your messages, receive them, and then deliver them. And then they are independently communicating with the broker. So as you can see, it helps in scalability in modern systems. So we want something like that. And then also, not only that too, in some cases, right, you also want the system, the messages, to be able to deliver the messages in order. For example, in some cases, right, not all applications require the ordering. But that's also another aspect that you want to kind of be thinking about if your system requires some sort of message ordering. For example, like you can be giving an example too would be like an e-commerce, for example, and you want to order something and certain things you want to make sure somebody clicking on a order and the other one, another terminal is also clicking on the order. Maybe you're using the same ID to place an order, something like that, and then somehow the data needs to be consistent ultimately, for example, things like that. So you want to make sure there's a system that's kind of capable of ensuring the message ordering as well. So, okay, so then it kind of then gets to this point was, we look into all of these requirements, right, for a modern system. In fact, it all requires a paradigm shift in the sense that, we need, I already hinted, is more of an event-driven approach in doing, for example, a change data capture type of situation. So now I want to introduce to you Apache Pulsar. And let me just real quickly give you an example, introduction, right? And essentially, Pulsar is an Apache open source project, and it's open source, and it was created by Yahoo back in like 2013 or so. There are people too asking, oh, is it like a Kafka on steroids? But I wouldn't describe it like that. I think I would call it like is cloud native DNA. It's born with that awareness of infrastructure. And it was donated to Apache Software Foundation in 2016. Then very quickly in 2018, it became a top-level project. And it's, by design, it's very cloud-native in, kind of by design. It knows all the stuff around you. But think of, that's the ideal, even though I'm not going to talk mostly about a Pulsar now, but just to know, this system is actually very amazing in the sense that it takes care of all of these infrastructural concerns that otherwise you would normally have to take care of it yourself. For example, if you do it in Kafka, you have like different offsets and all your messages. And then, in Pulsar too, there's no such thing. You don't need to worry about the offsets. And if, you are adding more brokers, adding, your topics is going to be partitioned, it actually, Pulsar knows and it will rebalance all of these things for you. So that's the kind of, capability of Pulsar. Very cloud native, true kind of cloud native and next generation of event streaming in the cloud. And not only that too, for Pulsar too, is that it's, your client, to interact with it, you want to use it, you're writing code. It's a PubSub, essentially, capability, PubSub message broker in there, but you can write code in Java and also C# too, and Python and Go, among some other supported languages too. So it's very flexible if you kind of think of having this. Not only that too, Pulsar will also separate out the compute and the storage side, and meaning that in any kind of messaging systems, that like we need to worry about what to do, right? You send the messages, but what to do after you send it. Essentially too, Pulsar, you can consider it as a messaging system, but it also persists the messages for you. It keeps the logs for you. So in big systems in which you're dealing with a lot of messages, then you want to make sure there's some way of managing this set of log messages. It's much like I like to describe it. It's like, we're having fun doing things, but we go out and do stuff, but we need to do our laundry. It's like all these laundry, you need to deal with. That they must be taken care of, but they takes a lot of energy out of you if you don't manage it properly. And Pulsar actually uses Apache Bookkeeper, this other project, which is like, as the name implies, it takes care of log messages in a very efficient way, like fast read and fast write and all of these things and many other kind of things with it. And it segments off all of the messages. So just FYI, so then you know that it is a very efficient system underneath the hood. Okay, another thing too about Pulsar too is built with guaranteed message delivery. So meaning that if you are sending messages, right, to a Pulsar broker, once it is there, even though the network goes away, something can be wrong. And don't worry about it, because once Pulsar receives your messages, I'm publishing the messages to it, it knows it, and even if something goes away, it knows after your network comes back, and it will deliver the messages accordingly to your intended target. And of course, too, as maybe some of you may know too, doing message delivery is not it's not a simple thing, even though you're thinking, okay, I'm sending messages between two endpoints, but many things can go wrong, right? The network can go away, all of a sudden something goes wrong, or maybe messages somehow never arrives, or kind of, it expire. So you have to worry about time to live, all of these parameters. Do you want to retain the messages after that? All of these things, and Pulsar has it built in. It will also helps with doing like retry, for example. It doesn't work, it will retry until it times out, and you can configure it the way that you need it to too. Okay, and then another thing too about Pulsar is it has also a function, a lightweight function framework, much like kind of Amazon Lambda type of capability. So it's very efficient because you can be transforming. It's a simple transformer, think of it like that. You have data that you're sending over, then you need to transform it. You can use the Pulsar, Apache Pulsar, writing your code in byte size essentially and deploy it. Pulsar will kind of do all of the things for you from the infrastructural point of view. You need to scale it. You need to, like in your infrastructure, you're adding another node or server, it actually will scale and rebalance everything for you, including these Pulsar functions too. It will take care of things for you. And then one more thing about Pulsar is that just highlighting among many other features is that it has a tiered storage offloads too. So basically, if you are, some data too could become cold, meaning that, you are in Bookkeeper is kind of keeping to, be in the storage, and it's no longer, warm, so to speak, and it's just waiting to be processed. And basically, Pulsar knows too, and it will move all of these cold messages to cold storage, essentially, so that it doesn't take room, in your hot area, that you need to take care of more urgent things. So cold storage, for example, would be like an S3 buckets and kind of lower cost. So then you don't get charged, as much too in more like long-term storage. So these are just some of the highlights of why, Pulsar is the choice. And this one too, just kind of quickly give you also a quick kind of pointing out Pulsar itself. It's has increased number of GitHub stars and contributors, and as you can see, it's kind of even surpassing that of Apache Kafka. I think folks are starting to recognize that Pulsar, in fact, is kind of less of kind of a hassle, for you to use if you are kind of looking for an event streaming type of platform, because it operates very efficiently in the cloud. So yeah, so that's what it is. And very brief history. Oh, this one I shouldn't put in here, but it's essentially just another repeat. But as you can see, it's a young project still, and I have to say too, it still has yet to be, have more implementations. But we're still at kind of 5 years old since became open source, or like 7 years old now, or 6-7 years old. So it still will take time to become kind of a kind of more robust. Let's put it that way. But their number of interests in this project is growing. So that's the important thing. Okay, so I kind of spent enough time, but just to share with you, you may be wondering who's using Pulsar. So these are kind of major companies in here that you can look at, among others. And also, too, not only that, we're talking about, using Pulsar to kind of be able to build data pipelines. And that's what we're illustrating in here. A change data capture pattern is essentially building data pipeline. You're sensing, right? We go back to the CDC, you're capturing some changes. And you capture it, and then you send it over to be processed, to be transformed. And so all of these kind of connecting pieces, we have a very rich ecosystem of connectors and clients too. And over here, for example, like language clients, right? There are all these languages that are, over here that are supported. And also, you can connect it to all kinds of databases in nearly all of these major, I think all of the major popular databases are supported. Meaning that these connectors are already pre-built, so you don't need to do much coding. You don't need doing so much to it. And I'll quickly show you how you can use our DataStax UI to actually connect to some of these connectors too. So, but yeah, so these are the ones. So as you can see, and also including not just databases, but other messaging, streaming workflow systems are included in here. Like Kafka, we work with Kafka as well. We can have Kafka sync, and we also actually have another API. If let's say you have systems that you're running Kafka, running RabbitMQ, you don't want to change it, you can also use our Starlight API, which is an API layer to connect Pulsar and Astra streaming to it too. Astra streaming, by the way, is our managed Pulsar streaming platform. So that's using Pulsar underneath the hood. So. Okay, so here too, I won't spend too much time now on the Pulsar side, but just to give you an idea, Pulsar components too, as you can see, there's the broker is the stateless process that handles incoming messages and message dispatching, all of these things. It's kind of more like the centerpiece, and as you can see, we can have multiple brokers, right? It's most of the time we're using multiple brokers because this way you can increase the throughput of your system going through. And then basically, there's also Bookkey. I mentioned to you Apache Bookkeeper. It segments off all of these log messages, and if you need to retrieve it, you can use API like a reader interface to fetch like some old messages and read them, and it's much faster using the reader interface too, pretty fast. So, and then broker is the one that receives messages from the producer, and then basically, to consumers that are subscribing to the topics, broker will send the messages to those consumers. And then now the Pulsar infrastructure is still using Zookeeper for managing all of the clusters and all of these metadata, things like that. So this is kind of a quick thing to show you, Pulsar. This I actually won't be spending as much time because I wanted to kind of, again, highlight a bit too. I know we're supposed to be talking about CDC, but just wanting to give you an idea too, is that Apache Pulsar is really the next generation of enterprise messaging and unified solution for PubSub, queuing, streaming, and message mediation and enrichment. So these are the thing. And if you have Kafka running JMS, RabbitMQ, for example, you don't need to change it. You can basically bolt on Pulsar because being so loosely coupled, you can use the PubSub and kind of bolt on and build your data pipelines and talk to these different components quite nicely because we have all these connectors already. Okay, so now I'll go back then and talk about enabling CDC. This time then it's about DataStax specific. We have a product called Astra, which is our managed cloud platform. So we essentially have Cassandra on the cloud and also streaming now too. But just wanted to kind of quickly point out too, change data capture. So we kind of go back now to more of the CDC. So in this case, too, the CDC feature at DataStax is only working with observing data changes in Cassandra, in our Cassandra cloud, Astra. Or if you use our system in which you want to use your Cassandra, we also have CDC for Cassandra as well. But this one, too, I'm going to quickly show you will be like our managed cloud platform. So essentially, if you look at it, right, you have a database table, and you want to use our CDC for Astra, and you can then set up your streaming tenant, so to speak. The streaming tenant is your Pulsar tenant. And again, Pulsar is a multi-tenant system. It helps you to organize all of your messages according to different tenants. So, I don't have as much time talking about the multi-tenancy, but it is actually very helpful in helping you to organize all of your data. Kind of almost seems like you have your closet of clothes. You want to have different shelves and things to organize your clothes. So it's kind of nice in that sense. So we have the tenant way of organizing all of your data. And then basically, too, then streaming tenant, you set that up. And internally, too, it will set up two topics. And it's one-to-one kind of mapping, too. You want to monitor like one column in your database table. And then you have a topic that's there where if there are any changes that it detects, the CDC will write it to that topic. That's the data topic as well as a log topic, too. And then once you kind of capture all of your data, you can transform it also using the Pulsar function that I mentioned earlier. Pulsar function is for you capture the data flowing through, you want to transform it, you can use that. And then after you transform it, then you can go deposit your outcome, your transformed data to the sink. So that's the streaming sink. And here is just a few examples. These are downstream target, right? You can write to a Cassandra and other Cassandra Sync or MySQL, Kafka, MongoDB, to another like JDBC to like Oracle or Postgres and all these snowflakes, for example. So it kind of helps too, in which you don't need to write as much code there. You can rely on this pattern, and also having Astra DB and capture all the changes and write it to your target system. So, and also, in fact, there's also Elasticsearch too that most of our customers are very interested in now, is that they want to be able to capture all the changes and then write it to a sink, which is Elasticsearch. Then you can immediately use that to process your other task of doing searches using Elastic. So, okay, let's see. Oops. Okay, so this I just wanted to explain a bit too. Again, I think here is at DataStax we have what we call like Astra streaming. That's the managed cloud platform, and it's Pulsar underneath the hood. And that's, of course, managed cloud, and yeah, it does have a cost to it to kind of use our service. But the nice thing is that we also offer like a $25 US dollar like free credit every month that you can use for maybe building your project for what you call like a project for exploring, right, for your own personal project. And that's pretty sufficient too. So that's Astra streaming, and I'll show that to you shortly. And then there's also Luna streaming. Is in that case, if you want to deploy your own Pulsar to your cloud and you manage it using Helm charts, for example, you can do Luna streaming too. And so in that case, if you use that and you would like some support, we also offer support, like enterprise support too. And then there's also the pure open source kind of version of it, in which is all community driven. You can participate in the community. And basically, yeah, these are the three kind of flavors that you can kind of think of having if you're interested in our product. So. And also, too, then it gets to like CDC, and as you can see over here is our DataStax investment in streaming-related products. And so on the right-hand side, the orange is basically the cloud offerings. Is Astra streaming, is Apache Pulsar as a service, fully cloud offering that's part of our Astra platform, the cloud platform. And then we also have a CDC solution for Astra DB that basically pushes data changes to Astra streaming. And on the left side is, again, you manage your own cloud, and you can use our Luna streaming. And then there's also CDC support, too, for Cassandra in this case. And in this case, too, we offer, too, for our customer manage CDC solutions for our DataStax Enterprise, the database non-cloud platform, or the open source Cassandra. So that's what this is. Okay, so now then I'll just show kind of a quick demo how do you kind of put your hands into using the CDC feature in Astra. Okay, over here. So I already have this in here. Let me go back. So I just have essentially two browser laying side by side, because I just want to point out to you, and if you want to try it, you can also go to this, this link too, which I have it on the slide deck too, if you want to get to this point. You can search for DataStax and then search for our CDC documentation. It comes up like this, and it has an example in here. So I just want to quickly kind of show that to you. And basically, too, let me see, over here, just wanted to get to the example part. You can create a tenant and a topic. So over here on the right side is the Astra DataStax.com is our managed cloud platform. Again, you can sign up for it. If you want, go to this website. Actually, they changed the interface. Okay, no problem. But over here, too, yeah, sign up, right? As you can see over here, if you don't have an account, you can sign up. So the nice thing is that if you click on it, signing up, it only asks you for your first and last name and then your work email address, but it doesn't matter. You can give a valid email address and set up your account. We don't need you to give your credit card number at all, which is nice. So, but in my case, I already have an account, so I go in and I sign in with Google. And like I said, this is all, you get $25 US dollar every month, so it's kind of a nice way to kind of experiment with this platform, and there's no obligation. And our salespeople won't call you too, so and I know it because I also get another account, nobody ever calls me. Maybe you get an email once in a while, so. Okay, so here we go. Now, just want to point out, this is, we have a new interface, like the user interface. This may kind of look a bit kind of older too, but there's a new interface coming, so it looks more modern, I suppose. So, okay, so over here, just wanted to show it to you first, right? You set up your DataStax Astra managed cloud platform. And when you come in here too, you can you can set up your database, that's Cassandra, or you can create also your stream, which is the Pulsar underneath the hood. So over here, let's see. I already actually set up some things to show you, but we can also follow this example so we can kind of step through it together again. But over here, if you need to create a database, it's as easy as you just click and then say create your database, give your database name, and also what is called a key space, which is kind of equivalent of a namespace. And then right now, we do support the three most popular cloud platform, which is Google Cloud, AWS, or Azure. So these are the three, and you pick your region, and then pretty much, and I'm not going to create one because I already have one created, but that's as easy as this, how you can create Cassandra on our cloud quickly. So, okay, let's go back. So over here, I already created a demos database. As you can see in here, I created one like using, essentially using Google Cloud in here, and my key space is e-commerce. So that's that, and wanting to also, oh, okay, let's see. Let's do that, but let's go over here now. The instruction as to how you can create a streaming topic, right? So over here too, like you go to our this managed cloud platform, and then you do create streaming. So create streaming. Let me kind of move back over here. So create streaming is here. This will be helping you to create a Pulsar stream easily. So let's say let's create a new one. This is JFocus, and then we can say how about. Okay, another thing too is if we use our CDC at the present moment too, you have to make sure your database region matches that, or your streaming region has to be the same as your Cassandra region. Yeah, there's a limitations currently. But in the future, we will be allowing for multi-regions. But for now, I just wanted to point out. So, okay, so over here, because I created Google Cloud, so I'm gonna use a Google Cloud for my streaming as well. So let's say over here, actually, let's do, which one? I have to look back again. I think I may be using US, so let me kind of double check. Oops, it's kind of, okay, so the demos is my database, so let me make sure. So over here, yeah, so I have Google Cloud, and the cloud area is North America, and region is US Central. So I want to make sure my stream also has the same region for now. So I'll just say JFocus stream. And then I can do Google Cloud, and then region will be US Central 1, right? Yeah, because I'm from Chicago, so I use Chicago Central. So, okay, so as you can see over here too, if you create a stream, it's actually pretty affordable. The right bandwidth, all of these are the cost is very affordable in here. So $25, if you want to experiment with that, is actually very sufficient. And then you can quickly create the stream. It comes up really quickly. And so over here, right, if you kind of follow on the left side, that's how you can create the stream through, by creating the tenant. And then basically in here too, we want to also create a topic, right? So topic is what will be like where the changes will be sent to as messages, right? So, okay, so that's that. And wait, where is it? Okay, sorry, but let me go back. JFocus stream, so in here. So as you can see over here, if you're kind of interested too, more like curious, right? And I'm sure we all are. And if you want to play around with how do I write a producer and consumer, just while I'm here, you can, as you can see, right, using this UI is actually quite easy, as a quick start. And if you kind of go in here to the quick start tab, it guides you as to how you can play around and get started with Astra streaming. How do you create a topic? How do you produce data? All of these, and let's kind of take a real quick look. To create a topic is as easy as you go to that tab and then do an add topic. Let's say a JFocus topic, and then we want a persistent topic. And just a note too, there's difference between persistent and non-persistent, but most of the time we want to use persistent because if your topic is not being used, after a certain time, then it will time out, and then if it's non-persistent, it will be removed. So you don't want that. So most of the time you want to use persistent, unless it's something temporary. And then in this case too, and we just wanted non-partition, so we can then quickly add a topic. And so it's as quickly as this how you can do it. So, okay, but let's go back, right? Go back to the quick start. If you want to produce data, you can kind of, let's say, click on Java. This is a Java conference. So we take a look at Java. How do you do it, right? And you can click on Java. Then over here in the bottom, how do you write a producer? How do you write a consumer? And CDC consumer over here, for example. It gives you some very basic guidance in here. So I find it to be quite useful, is what it is, because it's sometimes when you start, you don't know where to start, but having some guidance, this is very helpful. So, and besides, it's free for $25, so as a starter. So, okay, so that's that. But let's kind of go back then to we have some more, like 5 more minutes, right? So I'll just quickly go over here. And we'll kind of now take a look too. We want to create, in an example, we want to create a database now that we can actually be observing any changes that's written to the database. So over here, right, we can go to a database and we create a table with a primary column. primary key column. So, and actually I've already done that, but over here, as you can see, is basically just create a table. The syntax too for Cassandra, by the way, is they're called Cassandra CDL, which is similar to, or CQL, which is similar to regular SQL. So it, like you said, I mean, like I just said, it's basically create table is the same as how you write SQL. And so create table, if not exists, we create a table, and which I've already done that over here, just kind of normal syntax, and then you can select from your table and make sure it's there. So I have actually already done that part right before this. So let's go to our demo database. So my demo database is here, and if I want to take a look at, my table, so you can actually use the CQL console in here. And by the way, if some of you maybe are more prefer using command line client, like what you call CLI, command line interface. We also have Pulsar client too that you can use, but I'm just happen to be demonstrating it using the UI. And also there's from DataStax we also have Astra CLI, which is the Astra interface, our Astra streaming command line too. So if you like command line, you want to automate your jobs, you can always use the command line interface as well as we have SDK, you can write code to it. So, but again, this is what it is. And over here, as you can see, you want to interact with Cassandra. Right here, we have the console right there, built in for with the Astra DB. So in this case, I already created I think it's kind of small. Let me see if I can increase. Yeah, oh, I can. Okay, make it a little bigger. So over here, I can just do like over here, select star from, and my namespace actually is an ecommerce.tbl1. So as you can see, I already created my table, so I can tell there's already a table with just 2 columns called key, which is an integer, and then C1 is the text, and that's what we have in here. And then now we can then connect to CDC for Astra DB. So we will kind of take a look. We have to then enable CDC, in our database dashboard for this database, right? And so we can go to CDC tab, and over here, as you can see, okay, and over here, this is my table that has already been enabled for CDC, and over here, basically. I've already done it. So I've already done the part on the left side. And basically key space, I said e-commerce, and then table name is TBL1. That's already enabled, so you can see it in here, is enabled. And then over here, so okay, anyway, so this is what it is. But underneath the hood, basically, enabling CDC will create the new Astra CDC namespace. So as you can see, if you go back over here, there's also, wait, where is it? Where is it? Because it enable it, and then it also creates, I think I know why. If you want to enable this, you see that, wait, sorry. I meant to say that it actually, underneath the hood, it will create the Astra CDC namespace with 2 new topics. So this one is basically on the database side. You will see these. Oh no, actually, my fault. I'm trying to actually enable it, and then I am going over here, and I have to look into, is it over here, my topics? No. I kind of lost my train of thoughts, but in any event, it's there. My CDC has been enabled in this case. Okay, so then the next step is that once you have set this up, then you can immediately build up your connecting to an Elasticsearch sync. But I do have to kind of apologize today. I actually kind of made my own fault. I actually did not get a chance to set up an Elasticsearch sync right now, so then I don't have it. But I still want to step through the steps so then you are aware of how to do it. And of course, you can reference this page to see how to do it, right? So essentially, too, what you need to do is you basically will have to connect, this topic to the chosen table. And you pick the topic in here, and you add the input topic. And then you use your Elasticsearch deployment to complete all of the fields in here. So all of these two is you can find your Elasticsearch URL, and then define your deployment and some custom endpoint alias in there. And then basically, once you kind of get that set up, and then you can complete the remaining fields in here. And over here, as you can see, all of these things probably I don't have as much time to step through all of it, but that's the idea if you want to give that a try and send it to a working Elasticsearch sync in here. But the point of me showing you is that you can see that it can be done quite quickly, that you don't need a whole lot of setup in order to enable us change data capture things through your pipeline. So as you can see, this is how you can do it using our managed cloud platform. And over here too, once you define all of your fields for your particular connector sync, then you create it, right? It's there. Then you can start essentially using it to send messages. And when you send messages, in order to test it, then you can go back to your table and modify the table and add some data. Then you can immediately do a select to make sure that they actually it gets in some insertion happen, and then you can confirm that your Elasticsearch is actually receiving data. Then you have to go to your sync over there and make sure that data has been inserted, and then you can quickly see. In this case, it's this illustration in this is a strict pass-through. But in some cases, you can actually plug in like Pulsar functions, for example, to transform the data as it comes through. Maybe you want to filter some data out if it is greater than a certain amount or less than something. So that's the idea, how you can kind of enable like your CDC pattern using Astra database and Astra streaming in this case. So, okay. And yeah, so I have to say that it's just, like I said, I made a mistake, I have to say. I thought I was doing the other talk, and then I didn't actually realize I'm actually doing this talk, so I did not have a chance to set up my Elasticsearch sync. And I apologize for that. But the thing is, good news is that I do a Twitch stream, a live coding stream every Wednesday if I'm not traveling. So this would be something that I would like to do if you want to join me on my Twitch too every Wednesday. Normally I do it like Chicago time is afternoon, so it will be about 8, 9 o'clock here in your time zone. So yeah, so I'll be sharing with you my Twitch stream too. Then you know that it's not just for here, but it's kind of supposed to be, kind of a long relationship. I can be helping you in your journey too. So okay, I'll just go back to my slides because I only have maybe 2 minutes left. Okay. Okay, so just wrapping up, so where to go from here, and I'd like to invite you to keep in touch. And this is the page containing all of the resources, your Pulsar, Bookkeeper, I mentioned about Zookeeper, and also then the astra.datastax.com is where you can sign up for our managed cloud platform and use it, try it out for free for $25 per month, and you keep getting new money too every month, so that's nice. And then Astra streaming and Luna streaming, and also the bottom one highlighted is the CDC for Astra DB, and that's where I took the example from just now. So. And this one too, if you are interested in additional credits, right? Let's say you're running a startup company, we are very interested in helping you too if you want to use our product, Cassandra, Pulsar, all of these. So please use this additional, kind of credit for your this link, or contact me, or through me, I can connect you with our business folks and to help you too in your journey if you are setting up your business wanting to use our technology. And here, too, is just additional community information of Pulsar, too. In here, Apache Pulsar Neighborhood, which is a wiki page, and also then Slack group, too, if you're interested in Pulsar. And this is my Twitch stream, and again, every Wednesday at 2 p.m. usually, 2, 3 p.m. Central Time. So that's, well, sometimes it could be like 9 or 10 o'clock if it's not too late for you. Otherwise, too, it's being recorded, so you can watch that, too. And those there, I like to try to play around with things and really showing you how to do some stuff. And I can invite you to join me too on the stream if you're interested. So very flexible. So, and with that, I want to thank you again for having joined me today and really appreciate. So thank you. Thank you.
I think we have time for one question, but that's about it.
Yes.
Yeah.
CDC, how do you, yeah, that's a very good question.
Yeah.
I'm sorry, yeah. So, the question is, how do we guarantee consistency, right, of the CDC system, the data changes and all of these things? So, as I mentioned, right, like any kind of changes, then essentially it becomes, when you capture the data, then it becomes like it turns into messages sent to a topic, right? So you send to a topic, and Pulsar itself already has built-in guarantee, and also guarantee the integrity as well. So, and also, of course, to Cassandra, if you're familiar with it too, it also is a very high integrity type of database. I don't work on the Cassandra side, and I have more folks who know that better. But yes, but they are kind of, guarantee like consistency, it's there too. Yeah, so, yeah, but that's a good question, so, yeah.
Okay, I think we take more questions offline. Thank you very much.
Oh, yeah, thank you, Anders. Thank you again, everybody. Thank you, yeah. Oh.